Microprogramming for CNC lathe. Microprograms are mentioned in many programming languages, but what exactly is a microprogram? In computer science, a micro refers to a concept of batch processing. Let's first take a look at the ellipse shown in the figure. How can this workpiece be machined? In the previous chapter, we learned about linear interpolation and circular interpolation in CNC commands. But is there such a thing as elliptical interpolation? The answer is no. In a CNC system, if you want to machine ellipses, hyperbolas, parabolas, and other non-circular curves, the CNC system cannot directly achieve this, meaning it is not possible to generate such curve paths directly. So you need to machine an elliptical curve. An indirect approach is required, which is essentially a mathematical process. The mathematical method used is approximation, where straight line segments or circular segments are used to approximate such nonlinear curves, and circular segments are calculated. The start and end points of each straight line collectively known as nodes. Finally, linear interpolation or circular interpolation is performed to make the path infinitely close to the desired curve. By using variable operations in CNC programming, complex curved surfaces can be machined. This is the essence of microprogramming. Let's take the Fanuc CNC system as an example to understand micro-variables. Variable types include non-variables, local variables, common variables, and system variables. Local variables are effective within the scope of the current program. They only function within the same program number, and are used to store data within the microprogram. Global variables are effective throughout the entire part program, whether in the main program or subprogram. As long as the names are the same, they refer to the same variable and carry the same value. System variables can retrieve read-only or read or write information contained in the machine-to processor or NC memory, including exchange parameters related to the machine processor, machine status acquisition parameters, machining parameters, and other system information. System variables are special-purpose variables that are predefined within the CNC system and cannot be repurposed. In the Fanuc CNC system, variables are expressed as followed by a 1 to 4-digit number. For example, H1010. To reference a variable, it must be written in the specified format. For instance, F10 means that when 10 is equal to 20, F20 is commanded. The arithmetic operators in microprogramming mainly include plus, minus, multiple, and division. Function operators mainly include trigonometric functions, square roots, absolute values, and so on. Conditional operators mainly include equals, not equals, greater than, and others, all represented by special codes. An expression is essentially composed of constants and micro-variables connected by operators. There are also some commonly used control statements in microprogramming, such as unconditional transfer, G0T0 statement. As shown in the example, when the program executes the G0T0 statement, it unconditionally jumps to the statement labeled N within the same program to continue execution. Conditional transfer statement 1. If conditional expression G0T0N. When the condition is met, the program jumps to the statement labeled N within the same program to continue execution. When the condition is not met, the program executes the next statement, conditional transfer statement 2, where conditional expression D0M and M. When the condition is met, The program where D0M to end M is repeatedly executed. When the condition is not met, the program executes the next statement after end M, returning to the beginning of the lathe. How do we complete the programming for machining an ellipse? Let's first record the equation of an ellipse. Attempt to write a microprogram for the ellipse using parametric equations. Page 15. Let's take a look at an example of programming an elliptical segment using a macro. The previous steps involve some preparatory work. First, assign y-nodes to the minor and major axes, starting from the endpoint of the major axis. Therefore, the elliptical eccentric angle at the starting point is assigned a y-node of 0, and at the endpoint, it is assigned a y-node of pi divided by 2. Next, consider the loop statement we just learned, where 3LE for D01, meaning that when the starting angle is less than the ending angle, the program segment between D01 and end1 is executed. When the starting angle exceeds pi divided by 2, the loop ends. Within the loop, 5 and 6 represent the major and minor axes of the ellipse, respectively. The x and z coordinates of the nodes are calculated using the parametric equation of the ellipse. The next step is to use linear interpolation G01 to connect all the nodes on the ellipse through straight line segments. The command 3 is equal to 3 plus 0.5 increases the eccentric angle by 0.5 radians, gradually approximating the ellipse with straight segments. The loop exists, and the elliptical machining process is completed.